Good morning, everyone. So today we are going to see the properties of series circuit and parallel circuit, which is there in our DC circuit analysis. So first is a series circuit. So a series circuit is where two or one resistance is connected to one end of the other resistance. Then both resistance. So what will be the properties of the series circuit today now? Okay. So assuming this to be a series where R1, resistance 1, resistance 2, resistance 3, they all are connected in series. So as we can see here, when these resistors are connected across a voltage source, so where you can see the current I, so current I flows in this part. So that means same current flows to the resistance 1, same current flows to the resistance 2, and same current flows to the resistance 3. So the property of the series circuit, the first property of series circuit is current I is same in all parts of the circuit. So that is the first property. Next, going to the voltage. So as per Ohm's law, V is equals to I into R. So this is with respect to the Ohm's law. So now, if we want to find the voltage drop across the resistance R1, so V1 is equals to current flowing through the resistance multiplied by R1. Similarly, V2 is equals to current flowing to the resistance multiplied by R2. And V3 is equals to current flowing to the resistance multiplied by R3. So these are the three voltage drops which are there inside the series circuit. So the total voltage applied to the network or to the circuit is divided into number of resistances. So if there are three resistances, it is divided into V1 plus V2 plus V3. Okay. If there are n number of resistances, the total supply voltage will be divided into those many equal number of parts. Okay. So now the total supply voltage V is equals to summation of all resistance V1 plus V2 plus V3. So these are the three voltage which are there in this circuit. So the total supply voltage is equals to V1 plus V2 plus V3. So now here, from this we can derive the formula to find the total resistance. So the total voltage V is equals to total current I multiplied by the R total. So that is the total resistance of the circuit. This is the total resistance of circuit. Resistance of circuit. Okay. So as we previously written V1, V2, V3, so we need to substitute them into the circuit, into the equation. V is equals to V1 plus V2 plus V3. So V is nothing but I into R total, which is equals to I into R1 plus I into R2 plus I into R3. So taking I common on both sides, so I gets cancelled out both sides. So R total, that is for series circuit, is equals to R1 plus R2 plus R3. So that's how we find the equivalent resistance. Equivalent resistance when resistors are connected in series. So the formula we use when resistances are connected in series, that if any problem, if such thing comes, R1, R2, R3. So if you want to find the resistance between terminal A and B, so that is nothing but R total. The resistance complete from A to B is nothing but, because they are all connected in series, so the final resistance will be R1 plus R2 plus R3. So that we are using by this formula. So by using that, we are determining that in here. So that's what we are seeing. Next is the properties of parallel circuit. So when we can say the resistances are in parallel, when both the ends. So I am drawing a resistance R1 and resistance R2. Okay, these are the two resistances R1, R2. When both the ends are connected together, then they are said to be in parallel, like this. When they are said to be in parallel. Okay. So that's how the parallel connection are. So here as we can see R1, R2, R3, there's three are connected in parallel and they are connected across a voltage source. So first property of parallel circuit, because there is no element existing on here, so there is no element existing on this side, so the voltage drop, so applied voltage is same across all the resistances. So voltage V is same for all the resistances. So V is same voltage applies at R3, same voltage applies at R2, same voltage applies at R1. Okay. So you can say that all the voltage is only V. Whatever is the supply voltage, that is same to all the resistances. Okay. Now, as by same using Ohm's law, V is equals to I into R. So from here we can derive current I is equals to V divided by R. So based on this property, as we can see here, the total current which is coming from this part. So at this node, so this all becomes a node. So at this node, there are three parallel resistances connected. So the total current I divides into three. Okay. So how the current will divide? I1 is nothing but V divided by R1. I2 is nothing but V divided by R2. And I3 is nothing but V divided by R3. So that is current flows based on the value of resistance. So current always chooses low resistance part. So based on the value of resistance, current starts to flow. So at this junction, so the current, so in parallel circuit, current I is equals to, which is dividing into three parts, I1 plus, I2 plus, I3. So I is nothing but V divided by R total, that is in parallel. So that is V by R1 plus V by R2 plus V by R3. So cancelling V on both sides. So we have the formula to find the total resistance in this R1 plus 1 by R2 plus 1 by R3. So this is the formula to find in the what you can say equivalent resistance in parallel circuit. So that's how. In series circuit, R total is equals to R1 plus R2 plus R3. So this is for the series and this is for the parallel. So that's how we find the equivalent resistance in both. Thank you for paying the attention. Thank you very much.